I was looking for another example for you. All right, so I did. I really did. All right, so this first one says complete each table. These first two are not excessively difficult, okay? So we've got our input. We don't have a process table or column like we've seen in the other examples. We can add it. Like I said yesterday, it doesn't necessarily matter that the 3 columns are in any particular order. I would put the input column first, though. It makes most sense. But what am I doing from this input of 1 to get the output of 0? Subtracting 1, so 1 minus 1, okay? Now, there are other options. I could say, well, I'm taking 1 times 0. There's the idea that not am I subtracting 1, maybe I'm subtracting the input. So I'm taking input minus input. But that would give me zeros all the way through that right-hand column. Does that make sense, the output column? If I took 2 minus 2, give me a 0, 3 minus 3, give me 0. So does that process then stay true for the next one? Do I take the input, subtract 1 from it? The output ends up being the 1 again. The next one, take 3, subtract 1 from it. Does that give me that output? 4 minus 1 gives me that output. So the next one's going to be 5 minus 1, so it should be 4 there, right? Okay. What is real nice here, guys, and this is the purpose of structuring things so that our inputs are in a particular order. If I can see a pattern develop from my inputs that we created, so 1, 2, 3, 4, 5, 6, that's a pattern, and we see a similar pattern showing up in our outputs after we do, 3 or 4 examples. I'm right there. My outputs are 0, 1, 2, 3, 4. It's a boring pattern, but it's adding 1 every single time, right? So I can see then that the next one obviously would have been 4. The next one is going to be 5. The next one, when this would be 7, this would be 6. Does that kind of make sense? So my input we're calling in, and we're subtracting 1 from it, correct? Okay. What's the coefficient that is in front of that in right now? What's the multiplier? Huh? That's a 1, okay? Now, if you remember stuff from Algebra 1 with graphing lines and all that kind of stuff, our slope, if you remember, is y2 minus y1 over x2 minus x1. You guys remember that formula? Okay. It's also another way of saying it would be the change in y over the change in x. That triangle is the Greek letter delta, and in science and math it just means change, and in mathematics change means subtraction. So that delta y, that triangle y, means the same thing as y2 minus y1. Okay. But our outputs are our y values. Our outputs are our y values. That's what this is kind of gearing us towards. If I look at the change between those two, it's 1. If I look at the change between those two, 1 and 2, it's 1. If I look at the change between those two, it's 1. Okay? So that was the change in your y's. Does that make sense? Your inputs are ultimately going to be our x values. And the change in those is 1. 1. 1. 1. And then if my y2 minus y1s is always going to be 1, and my x2 minus x1s is always going to be 1. 1 divided by 1 is 1, right? Does that make sense? So my slope, okay, or my what we call rate of change, which is the coefficient that goes with your variable, is 1. That's why it's a 1 in out in front right now. Okay? Let's skip over this next one, because I think the next one is one that you guys can probably manage on your own. And now you don't have this one, but I'd like you to just take a quick minute to jot that one down. So when we look at so I want to give you, like, you can do the idea, okay, what can I do with the 1 to make it a 6? Well, I could add 5. Does that then give me the same thing? When I go from 2 to get to 10, well, not really, so I'm not adding 5. So then maybe you say, okay, well, maybe I'm multiplying the 1 by 4 and adding 2. Does that help me go from 2 to 10? I think that does. But it's kind of like a trial and error type thing there. Does that make sense? And that can be time consuming. You can maybe spend 10, 15 minutes on it and not necessarily generate what the rule is supposed to be. So the process, I think, can be seen a little bit easier if I go through what we did on that last one and we start looking at that difference between those two. Okay? And I'm always going to, like, when I go from 6 to 10, I'm adding 4, right? So I'm going to make sure it's positive. If I was going from, like, 10 to 6, that would be removing 4, so I'd write a negative 4 there. But it's a positive increment, so I'm going to add 4, so it's a positive 4. That's a positive 4. That's a positive 4. Does that kind of make sense? That's a good thing to see there, okay, that plus 4 plus 4 plus 4 was consistent, okay? That's going to help us verify that this is going to generate essentially a line, okay? Now, I also need to look at the input, and I need to look at what their increase is. Plus 1.
Pardon the interruption. This time, freshman with last name P as in Princeton, and S as in Salinas. Two new teachers in the building. May report to the gym for patients this time again. Freshman P through S. Thank you.
I don't know, like that. Yeah, it seems like a very small cluster of people. I don't know. Maybe there's a lot of freshmen with those last letters. But if I look at those two, so we got the 4s on the right-hand side. That's consistent, right? Our input on the left-hand side is all plus 1. That's consistent, okay? And before we do that, we have to first make sure that we've got the order of our input, and it was 1, 2, 3, 4. It's not just random, okay? We want to have that structure. So now what that tells me, guys, is that when I create my rule, the coefficient that goes with n is that number that we saw over here divided by that number that we saw right there. Does that make sense? So 4 divided by 1 is 4, right? So that generates my coefficient. If you remember back to Algebra 1, that's the slope, okay? Okay, but that's not my rule because I take my input of 1 and multiply it by 4. It doesn't give me the 6 I need, right? So if I go 1 times 4, I get 4. What do I need to do that to get to 6? Plus 2, right? Okay, so I think I can amend my rule a little bit and see if it's 4n plus 2. Now I'm just going to check to see if that generates the other output. So if I go to the row that says 2 as my input, 4 times 2 is 8. Plus then 2 gives me the 10 for my output. And then we'll try 3. 4 times 3 is 12. Plus 2 gives me the 14 of the output. Does that kind of make sense? And that's a more streamlined, more efficient, quicker way to find that rule than just to look at the input and kind of guess what's happening to find the output. Does that make sense? Okay. We got one more for you, and then we'll get logged into Math Excel. So go ahead and copy that one. All right, so if we look at this one here, your input's a little bit different, right? Structure a little bit different. In the past, I think they've all increased by 1. Okay, so this one's going to incorporate us having to recognize that. Okay, but if I go 12 to 22, increase of 10, right? 22 to 32, same increase. 32 to 42, same increase. Okay? Now, there will be situations, guys, later on when it's not plus 10, plus 10, plus 10. Maybe it's plus 10, plus 12, plus 14, and they vary. And we'll talk then, okay, well, if that happens, what do we do next? Okay? But right now, they're all plus 10, so that's good. Okay? Let's now look over here, and we get a plus 2, right? Plus 2. Plus 2. And that's what we always want. We always want, no matter what, if the plus 10s are the same or if they're different, we still want the inputs to have that pattern of either plus 1 or plus 2 or plus 3 all the time. And that just tells us that we've structured them correctly. That's going to allow us to recognize this pattern over here. But now, if you remember, what we're going to try is we're going to take that number, because these are all the same, and that number, because these are all the same, and we're going to divide them. Last it was 4 divided by 1, so we just saw 4. But now if I divide them, I get 5, right? Because remember, this was your change in y's. Change in y is 10. This was your change in x, and that's 2. So we go 10 divided by 2 gives me 5, right? That 5 is the coefficient for my variable. It's the coefficient for the n that we're going to use. And now we just have to see, okay, is that my entire rule, or do we need to adjust it a little bit? So if I go to my input of 2, and I multiply it by 5, does that give me the output of 12? Gives me 10, right? So what do I need to do to that 10 to get to 12? Add 2. So we add 2. And now we're going to see, does that happen? Does that rule work with 4 then? Does that give me the output of 22? Well, 4 times 5 is 20, plus 2 is 22. We can keep checking them, but those are all going to check out then to be generated by that rule. Does that make sense? And I think that, guys, that process is going to be a lot easier than just kind of a check and guess process. Okay. Now here's what I want to make sure we understand. Okay, so I just took the same exact data points that I provided you to begin with in that first question, and I just reorganized them. I just jockeyed the inputs around and then attached the correct outputs to them. But if I do that, you look at the outputs, and it looks like there might be a pattern there, but it's a very small pattern to see if it really go negative 20 to plus 10 and negative 20 to plus 10 and negative 20. So I doubt it does, but there's no pattern on the right-hand side yet. And there's no pattern that we see on the left-hand side. Does that make sense? Okay. The only time that we're going to be able to recognize that we have a true pattern over here is if we have a true pattern over here. And that's the structure that we want to maintain. We want to make sure that these are increasing. It's usually what we do. We want them to increase. They could decrease, but it's usually not necessary to worry about them decreasing. Start at 0, go to 1, go to 2, go to 3, go to 4. Start at 0, go to 2, go to 4, go to 6, go to 8. Start at 3, go to 6, go to 9, to 12. Does that make sense? So we're always keeping a consistent pattern. Whether you're skipping 1 value, 2 values, 3 values, 4 values in between, you still have a pattern there developed in the input, and that's going to help you recognize that pattern in the output. Does that make sense? Okay. So just want to make sure that is happening. When we get in our homework, generally when they provide you the table, they do that for you. Everything in the input is going to be in order. You don't need to rewrite the table. But if we're just pulling stuff from collection of data that we've collected, we would want to make sure that they're in order like that.